Hello there, and welcome to the first in a series of videos for physics students at the University of Liverpool. My name's Rob, I'm from HiPy, and we've produced this Jupyter notebook for you to sing along and complete the exercises that are going to be associated with your Python module. So, before we start, just a bit of a plug for our upcoming HiPy events. If you feel you would like some additional support for learning Python, that's what we are here for, that's what HiPy does. You can click on any of these links here. I'll post the link to this notebook in the video link below, and you can register for any of these events now throughout the term. They're quite large events, they're very informal, very friendly, we've got a good team of people, there'll be lots of people doing lots of different things, but if you have specific questions about Python that you need answered, do come along, someone will be able to help you, I guarantee it. Okay, so everything you need for the following videos are going to be at this link here. Let me just show you what that looks like. Okay, so they're in this GitHub repository. The data that we're going to be working with is this XRF test data here. Let's just open that and have a look. Let's download that, open it up, cancel that, oh, blimey neck. There you go. Right, so we've got a load of data here, which is actually X-ray fluorescence data taken on one of the lab spectrometers. And we've got data for zinc, copper, nickel, iron, silver, and then you've got a couple of unknown materials there, which actually we're going to try and determine eventually what they are based on the calibration curves that we determine from all this other material data. Okay, so generally most of these have two scans taken at two different gains, so we can calibrate for different gains there. And I think the only one that we might have a bit of a problem with is silver, because we don't know that data, but I think I do know it elsewhere. Right, so that's what the data looks like. Make sure you can get a hold of that data, and make sure this data file, this Excel spreadsheet, is saved within the working directory from which you are running your Jupyter notebook. That is very, very important. Okay, let me close that down. Let's go back to our notebook here. And so I've got this sort of blank notebook with comments in each of these cells. I'm going to start typing, and if you try and follow along, the first thing we're going to try and do here is we're going to try and read that Excel file into a format that we can manipulate. Okay, so the first thing we need to do is make sure we've got the modules we need to do that. So I'm going to be using pandas. Now, if you want more information about pandas and you haven't used pandas before, definitely go and check out our HiPy resources. Pandas is an amazing resource for essentially reading data from things like CSV files and Excel spreadsheets, which actually allow you to really easily manipulate that data without having to sort of read every single line as you might have been doing previously. Okay, so let me do that. So we're going to import pandas as PD. I usually have that line somewhere in any script that I write. Also, we're going to use NumPy, good old NumPy, as NP. And of course, I'm going to be doing some plotting, and I'm going to use our sort of intrinsic, workhorse for plotting. That's matplotlib. And I tend to import it by that, run that. Okay, so that's all I need to worry about now. Now I'm going to read that file, okay, and I'm going to read it using pandas. So to do that, I'm going to create what I call a data frame. Let's call it df, that's the variable name. And I'm going to say pd, so I'm calling my pandas library here, and I'm going to call the method from within that called read Excel. And I'm going to remember the file name, it was XRF test data.xlsx. Make sure you get that right. And I am going to do a bit of jiggery poker here. I know that in that data set, I don't want to worry about the header. When you read a data file using pandas, it will automatically assume that the first row in your Excel spreadsheet are column names. Okay, now that's not the case for this data. So I'm going to say header equals none. And the other important thing I need to do is specify the sheet name. Pandas will only read the first sheet of your spreadsheet by default. I think the first sheet was zinc, but I'm actually going to read the copper sheets. So sheets name equals copper. Okay, and you can get those sheet names from the tabs in your Excel spreadsheet. Okay, I'm going to run that. Okay, no errors. That's good. If you want to take a look at what that data frame looks like, then I'm just going to type df into another cell and take a look. So that's what the data looks like. Okay, and if you go back and you look at your Excel spreadsheet for that sheet, it will look very, very similar. You'll notice that where there are blank cells, Jupyter Notebook, Pandas gives it an NaN value. We'll worry about that in a second. And that's all the data we need. So it's a bit scruffy because we really only want these values here, which are our X and Y, which we're going to use to plot the data. So there are actually two data sets here at two different gains. So we need to find a way of getting this to an X and a Y and this to an X and Y variable. Okay, so let's do that now. Let me get rid of this line here. So, okay, so how do I do that? Well, let's say we've got, let's say I just want that first set of copper data for the first gain. It was a gain of 2, right? I'm just going to call a variable copper12, so copper underscore 1, and I'm going to call my data frame that I've defined above, and I'm going to use this method called ilock, and I'm now going to specify a range of cells. So I'm essentially creating a sub data frame from my original data frame, and I can do that by specifying the coordinates of those cells. To do that, I'm going to use a square bracket. At first, I'm going to specify that I want the rows, so I want every row after 10. I'll go back and look at this now. Actually, it might be useful if I can see this data. There you go. So I want every row from 10 to the end of the sheet, end of the data frame. Okay, so let's put that in. Okay, so that's what the colon means. The colon means to the end of the data frame. And now I'm going to specify the columns. Well, I know I only want columns from the beginning, so let's just start from 0 to column 2. Okay, and that will give me just the copper 1 data frame. For the second data set, which was a gain equals 4, I'm going to specify, I'm going to do exactly the same thing, and again it's just from 10 onwards, and I'm going to go to, actually this time I need to look at row, so 3. So column 3, everything from 3 onwards, I want to get this data out. So I'm going to get all of the columns, the rows after 10, and all the columns after 3, including 3, right? Let's do that. So this time it's going to be 3 onwards, okay? And if I run that, I don't get any errors, which is good. And if I want to see what that data looks like, I can just do copper 1, and there you go. I've just got X and Y data here. These bold are the index values of the rows, which are the same as the original data frame, but I've got all of those values in here. So I have now got those, I've read that data into 2 separate data frames, which I can now use to manipulate and plot that data. So that's it for this video. Join me for step 2, where I'm actually going to plot that data. Okay?